So in this video, we're covering control flow from Xcode using if statements. And so let's get started and see how this works out. So first of all, we have a variable here called foo, and it's given an initial value of 8. And then basically we want to make a decision on this value. We want to test whether foo has a certain value or not, and if it does, print one thing, and if it doesn't, print another. So the way we can do that is with an if statement, right? So we type in .if space, and then normally a lot of languages would require you to do an open paren and put your condition in a parentheses, but we don't need to do that in Swift. So I can literally just say, if foo, let's say, is greater than 10, so this is a Boolean condition, and our if statement is going to take one branch or another in the code based on whether this evaluates to true or false. And the true case is going to be first, and we do that by doing an open left bracket. I just hit enter here, and Xcode closed it for me with a right closing bracket. So these two brackets are critical, right? This is the code that goes right here in this section is going to be all the code that runs if foo is greater than 10. And if foo is not greater than 10, then it's going to just skip this section of code. So let's try this out. If foo is greater than 10, how about we print foo greater than 10? And then I'm going to come down and right here afterwards, I'm going to say print, we always do this statement. And the reason we would always do this statement is because we're testing if foo is greater than 10, and only in the true case do we do this. However, whether this happens or not, this statement will always execute. So let's try that. So I'm going to do Command R here and run it, and it says we always do this statement. So it didn't do this, right? It did not do this because foo is at 8, and it was testing to see if it was greater than 10. So what if we make this 12? So if I make that 12 and I do a Command R again, I now see foo is greater than 10, and we always do this statement. That's right. So this is the demonstration of a branch, and it's fundamental to computer science and computers. The actual aspect of this is that if we didn't have the ability to manipulate our control flow, we wouldn't have computers. So this is fundamental. Now, let's just take this one step further and look at what if we want to do one thing if foo is greater than 10, but do another thing if foo doesn't pass. So in this case, we can put an else in here and do another open bracket, hit enter, get a closed bracket, and again, these things need to match. And here we could say print foo is not greater than 10. So now when we run this, let's make foo a 9 here. We should see this statement run, and we should see this statement run. So let's try that. And it says foo is not greater than 10. That was this print statement here. And then we always do this statement. That's right. We're always going to do this statement down here. So this is the classic if then else. So if the then is implied, and that's through this bracket, the else is through this bracket. And I can't stress how important these brackets are. Another thing is some languages, because it's a single statement, allow you to just get rid of the brackets. And so, for example, it might allow you to do this. That would be true potentially in JavaScript and in C, but Swift does not allow that. So Swift always wants to see these brackets. It makes your code clearer, and it's easier to read. Now, the other thing is this left bracket also doesn't need to appear right here. It could go here. And so on this else, we could put that down here. Now, if you prefer that way of looking at your code, feel free to do that. However, I will tell you, kind of the industry standard is to start this bracket right here on the same line right at the end. So here we've done the control flow. One other thing I want to just jump into here is also show you the debugger. and just a quick introduction to it so you can see how this works. What the debugger allows you to do is actually step through your code line by line and see what's really going on. So it's really a great tool. The way I can invoke the debugger is I can literally go over here, let's say to this line right here, line 5, and I can click that right there, and I get this big blue indicator here, and that is what's referred to as a breakpoint. What that means is when we start executing this code, if the computer comes up to a breakpoint, it will stop. And then we can examine variables and do other things. So let's try that. If I do Command R now, instead of it running all the way through, note we have a green message here saying we are at breakpoint 1.1. You don't really need to worry about what this says over here. You just need to know that this is where you stopped. And if you come down here, you can see in this variables window that it says foo equals 9. And that's correct. This is what the value of foo is. I can also put my cursor over foo, and I can see the value there, and the value is coming back as a 9. Now, what we want to do is say, well, where would we go next? So we can literally step forward a statement, and we do that down here. You'll see this sort of step over, and what that's going to do is it's going to step over this condition, and we're going to end up somewhere else depending on how this condition evaluated. Well, we know that foo is not greater than 10, so when we step over it, we should land here on statement 8 in this else. So let's see if that happens. I'm going to hit the button, step over, and sure enough, right here I have my breakpoint is on this print statement. And notice nothing's printed down here yet, but if I step over that print statement, now I see that the print statement printed, and we can go step over again, and now we are at this one, and we can, if we want to just run at this point, run to the end and continue until we hit another breakpoint, we can just hit this play button there, and we've run to program completion. So that's a really neat tool to use when your program seems to be coded correctly, but it's really hard to figure out why is it really taking the right paths through the code. I encourage you to use the debugger. Let me also show you one other thing. What if we said, if foo is greater than 10, do this? And what if I added in here a foo is going to be incremented by 1, and that means that when we get to this print statement, if foo, let's say, is 11, then we say, is 11 greater than 10? It is, so we would go here. We would add 1 to foo, so that would be 12. So when I get to this statement right here, I should find out that foo is 12. So let's see if that's true. So I'm going to hit the line right here to hit that breakpoint. To get rid of this breakpoint, if I don't want it anymore, I can click once, and that kind of de-highlights it, but it didn't really take the breakpoint away, but it's no longer active. If I really don't ever want a breakpoint there again, I don't want to remember that spot, I can literally hold down the left mouse button and slide it away, drag it away, and that will delete it. So now let's run again. So we're going to do Command R, and we should break, which we did on line 7. And now if I put my cursor over foo, it says foo is 12. And down here I see that foo is 12. And that's because it was incremented by 1 here because we took this path, and we are able to examine variables and see how things go. So from here I could just say move forward, and it has run to completion, and I have all of my output down here. So that is the if statement, the if-else statement, how we do the bracketing, which is very important, and I've given you a little introduction to using the debugger.